Now, I want you to think about in your car, right? Now, I'm not sure where you're at in the world. If you're in the USA, your car will say miles per hour. And if you're somewhere in Europe or some other country, almost certainly it'll say kilometers per hour. But notice the units of speed, right? It's miles per hour or kilometers per hour. So it's distance on the top per hours, or time on the bottom. So it's always distance on the top of the unit, time on the bottom of the unit. And that means that you already know the equation for the average speed of anything. It is how far did you travel, the distance, how far did you go, but divided by how long it took, the time interval. All right, the time interval. So we're going to do we're going to have an entire chapter on basically dealing with speed and time and all that. But just as an introduction, if I know how far I went, like 10 meters, let's say, but it took me 2 seconds to do that, then to find the speed here, I would take 10 divided by 2, I get 5. And the units would be whatever unit of distance and whatever unit of time I use, so meter per second, for instance. But the thing I want to really call your attention to before we get into that kind of detail is I want you to remember from the last section, the distance was defined always to be positive because it's not a vector. The distance just told you how far, whether I'm going that way or that way. So the distance in this equation is always a positive number, just by definition, because we always just threw the sign away. Now the time interval we haven't talked about, but you all know that time only goes one way, right? So the time interval always is a positive number, right? We're always going forward in time. So the time interval here means that the bottom number, this is always positive. So if I take a positive number, the distance I travel, and divide it by a positive number, the time that it takes, positive divided by positive in terms of integers, you know, is always going to give you a positive number. So what this means is that the average speed as a quantity is always positive. So because it's always positive, it can never have a negative, average speed can never have a negative number associated with it. That means it's not a vector. Because vector quantities have to be able to convey direction. They have to be able to tell you you're going that way or you're going that way. But we're telling you, because we're basically using this is not a vector and this is not a vector, we divide both of them positive numbers always, we always get a positive number. So speed, average speed, is not a vector. It's still useful. It tells you how fast you're moving. It just doesn't tell you if I'm going this way or if I'm going that way. And think about it, in your car, you don't need to know that because you know which way you're going. You're driving left or right on the road. You're driving east or west. You don't really care about the speedometer telling you that. You just want to know your speed. How fast are you covering distance along the ground, divided by the time it takes you, there's distance per unit time. So to give you an example of this, just a quick example, let's go back to our friendly neighborhood number line. So we'll have 0, 1, 2, 3, negative 1, negative 2, negative 3. So we'll write these down like this. Now let's say, for this simple example that we're doing here, that my initial position, I start out at this position, x is equal to negative 2. Maybe I'm negative 2 meters from the front door to the left of my house. That's my initial place I start from. And then I start going to the right. Maybe I'm walking, maybe I'm riding a bike, maybe I'm flying in a missile or an airplane. But I end up over here, right here, and that's my final position. So obviously I can calculate the distance. I know what the distance is, 1, 2, 3, 4. I went 4 units over to the right. But what I want to really calculate is the velocity. So I have to know, the speed. So I have to know how long did this distance travel take. So in my problem statement, I'm going to be told that I travel between an initial position of negative 2 and to a final position of positive 2 in 1 second. Only takes 1 second. Done. So what's my average speed? So the average speed is equal to the distance divided by the time, right? So the distance divided by the time. Now you can see the distance right here. You can do a number of ways. You could just count 1, 2, 3, 4, or you could say, well, I know the displacement is final position 2 minus a negative 2 means 2 plus 2 is 4. So I can say 4, and I can take the absolute value, and you're still going to have 4. So no matter how you slice it, the distance covered here is 4 meters. This is in meters. okay? The time elapsed, you have to know how long it takes you to calculate any kind of speed. It's just 1. The unit on the top is meters. Put it right here just to show you. The time on the bottom is seconds. When I divide them, I get a number of 4, and the units stick around, so it's meters per second. So that is the average speed, meters per second. Now, speed does not tell me the direction, so I know I'm going 4 meters per second. I know from looking at my diagram that I've traveled to the right, but the average speed doesn't tell me if I'm traveling right or left because the input into it was distance, and distance means I threw away the sign anyway. In this case, it happened to be positive, so it's the same number, but in general, if I'm going the other way, I'm going to put the positive distance in here to get this speed. That's what speed is. It's basically your velocity without any sign. So I take away all the signs, I throw them away, and I do the division and I get the speed. So there we go. This guy is always going to give me a positive quantity. Average speed is always going to give us a positive quantity. So let me go ahead and circle that. That's my answer to this problem. I traveled 4 meters per second. All right, so now we want to define, over here we defined average speed, so let's go ahead and talk about its cousin, average velocity. I've danced around it, and you probably can guess what the formula for average velocity is going to be. Here, the formula for average speed was distance over time. Here, average velocity is going to be, what do you think? Displacement, which we learned about in the last section, over time interval. Right? Now, because displacement from the last lesson can be positive or negative. Remember, if you're going to the right, it's a positive displacement. To the negative, it's left, it's a negative displacement. But the time interval is always positive. You can never have really negative time. So, well, we're not talking about crazy things like quantum mechanics or special relativity or anything here. But in general, time is always marching forward, so you're always going to have positive time here, positive time intervals. But the top can be positive or negative, so if you end up with a negative top and a positive bottom and you divide them, you might get a negative answer. But also, if the top were positive divided by positive, you could get a positive answer. So the bottom line is the average velocity can be positive or negative. And because it carries a negative or positive sign telling me the direction of travel, we say velocity or average velocity is a vector quantity. And the way I want to write it down, yeah, I'm doing it this way and writing it in words, that's great. But the way you're going to see it in the physics book is going to be like this. Average velocity is going to be equal to, what is displacement? It was delta x, remember? And what is time interval? That's some words, but we write it as delta t. That means change in x, how much did I change in my distance, divided by how much did I change in time. In other words, that's the definition of a time interval. How much did time change? How many seconds elapsed? Okay. So if you want to spell it out even more on the top, it'll be the final value of position minus the initial value of position. Remember I said that's what delta x was always equal to, final minus initial. On the bottom, it'll be the final value of time minus the initial value of time. All right? So this is change in x, final minus initial. This is change in t, final minus initial. So this is important. I'll circle that. And of course, we don't really need to circle it. I'll just kind of do this. I'll kind of circle it, I guess. This is important. I mean, that's the title of this entire lesson. The whole thing is titled Average Speed and Average Velocity. And the reason it's important is because before you take physics, you pretty much think speed and velocity are the same thing. And the reality of it is speed and velocity are very, very close, but they're not quite the same thing. Velocity is going to tell you how far you move divided by how long it took, in meters per second, in other words. The number will tell you how fast you're going, but the sign in front of when you calculate, you're going to get a negative or a positive answer. If you get a positive answer, it means you're moving to the right. If you get a negative velocity, it doesn't mean you're going to another dimension or something crazy. If you get a negative velocity, it just means you're going the other way. So it's really useful because if you have a ball traveling this way, and it might be colliding with a ball traveling this way, well, guess what? The ball going this way to your right is going to have a positive velocity. So I'll write my equations with a positive velocity. But then this ball's going the opposite way. He's going to the left. So he's going to have a negative velocity. And the signs of those velocities keep track of the directions for the collision to happen. So the signs are very, very important. So velocity, average velocity, is a vector quantity. It has size and it also has direction. Whereas speed is the exact same number as velocity. It's the same calculation, except we just threw away the sign. So we get positive answers for our speed. It's just like displacement, or very similar to displacement and distance that we talked about earlier. One has a sign and one doesn't. One's a vector and one's not. So let's go ahead and do a couple of quick examples. Numeric example. I already did one of them, but I want to drill it in more because it's really important. Here's a number line. So we'll do 0, 1, 2, and then we'll go -1, -2, -3, -4. This is -4 here. Of course, you can fill in the blanks with this guy right here. And my question says, you know, in your book or whatever you're given in an exam or something like that, it might say you move from the initial position to a final position in 3 seconds. Right? And it might tell you the initial position is -4 meters, and the final position is +2 meters. And I want to calculate the average velocity, how fast, you know, the meters per second, right? And also the average speed. Okay, so how do I do that? Well, the first thing I might be inclined to do is plot this. You don't have to. You certainly don't have to, but let's do it. We have it right here. The initial position was -4, so that's why I put -4 here. Initial position was here. The final position was +2 over here. So we're going to say this is the final position over here. So what happens is you start out here and you start moving. And this distance traveled occurs in 3 seconds. So it defines a distance and a time so you can calculate a velocity. All right. Now, without doing any calculations, you know because you start here and you move to the right that this velocity is going to be positive, because positive is always towards increasing x and negative velocity is the other direction. So that part you got down. Let's just see if it matches reality. So the average velocity is going to equal the change in x divided by the change in time. And we define change in x as displacement. That's the final minus the initial distance. And of course, you can write this down as final minus initial time, right? So next thing we do is we take a look and say, what is our final position? It's going to be 2. And we're subtracting our initial position, -4, but we got to be careful and put that -4 in parentheses because we're subtracting the initial position, which happens to be negative. So we got to keep it separate. On the bottom, you have the subtraction of time. You might not want to know what to do initially, but you're given that it was a 3 seconds elapsed. So really the difference in time interval is 3 seconds. What it means is when I take my final time and subtract my starting time, they're 3 seconds apart. Elapsed time is always going to be positive because the final time is always going to be bigger than the initial time because time only goes one way. There is, I mean, yeah, we can think of negative time, but we never travel that through negative time. So your delta t is always going to be positive in the bottom. So what we do is we notice the double negatives here. So average velocity on the top is 2, but the double negatives make a positive. So 2 plus 4 over 3 is 6 over 3. So what do you have? Average velocity is 2. And what are the units? Well, it was 6 meters that I traveled 3 seconds. So it's meters per second. And I circle that as my average. As my answer. Average velocity is 2 meters per second. And then I say, okay, great. What's the average speed? This could be a good test question. Average speed. All you do is you take the average velocity and take its absolute value. And in this case, it also becomes 2 meters per second. Because when the velocity is going to the right, the speed and velocity will match. But you know that this sign here means +2, which means it traveled to the right. From its starting point, it went to the right. If we had gotten a negative answer for the average velocity, we would have gone to the left. Average speed, however, is always going to give you a positive number. So let's do one more where we flip things around, we start somewhere and we go in the reverse direction, and it shouldn't be a huge surprise that we'll get a negative velocity. So final problem, we have a number line here, and we'll start here at 0. We'll go 1, 2, 3, 4, 5, 6, and we'll go -1, -2, -3, -4. Right there, you can fill in the blanks on all the other things. And then what we have here is we are told we walk from xi to xf in 6 seconds. And you're told that the initial place you start walking from is 6 meters, x is equal to 6 meters, and the final destination that you get to is -4 meters. So let's do it without plotting it on the number line first, even though the numbers are small and you can probably figure it out in your head. Let's calculate it without doing that first. The average velocity is going to be equal to the change in x divided by the change in t, displacement over time. So that's the final position minus the initial position divided by the final time minus the initial time. Now, what do we have here? The final position, look in our problem, we're told it's at -4 meters. And we subtract the initial position, which we're told is +6 meters. So you just plug them in straight away. And then you have a elapsed time, which you're told is 6 seconds. And I've already told you, just stick that in there. There's no reason to subtract anything because elapsed time is given to you in the problem. So then the average velocity is what? From algebra, you know -4, and you subtract 6, so you go even 6 and more negatively. So you're going to get -10 on the top, and you'll get 6 on the bottom. All right. Now you can leave it there if you want, but let's simplify this fraction. We can simplify it because I can divide the top by 2, and I can divide the bottom also by 2. As long as I do the same thing to both, I'm fine. So the average velocity, -10 divided by 2 is -5, and 6 divided by 2 is 3. So I get -5/3. So the average velocity is -5/3, what? Meters per second. And if I want to stick that in a calculator and take 5 divided by 3, of course it's negative, you get -1.67 meters per second. That's the average velocity. What would be the average speed? Average speed is exactly the same calculation, but with the sign stripped away. So you take this and you strip it away. The way you write it down mathematically is you take the absolute value. So it's 5/3 meters per second, which is, take the sign away from this, 1.67 meters per second. That's the average speed. All right. So let's see if we were right. Let's go up here. Our initial position was 6 meters, way over here. Our final position was -4 meters, way over here. And let's see what happened. Well, I started here, and I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units, but I went to the left. So I went 10 units to the left, and I divided by how many seconds? 6 seconds. So the answer I got was a negative average velocity, -1.67 meters per second. So I'm traveling at a speed of 1.67. That's taking the sign away. That's my speed. Speed doesn't tell you if I'm moving left or right, though. Speed just tells me how fast I'm going. But the velocity carries the sign information. Negative means traveling to the left. Positive means traveling to the right. And it reflects reality exactly. Now, I'm going to get into this a lot more later, because what we're going to do is we're going to take a break from speed and velocity. We're going to talk about vectors for quite a bit in a little more detail. But eventually, when we get later in the course, we're going to come back to speed and velocity in a whole lot more detail and doing a lot of different analysis of different kinds of problems with speed and velocity. But one thing I want to leave you with, just to kind of get you thinking about in the back of your mind until we come back and visit speed and velocity. Notice that we said we started here. Let me go back to the positive problem, actually. Make it be a little easier to think about. We started here, and we ended up here. So we traveled to the right. Okay? When you do a calculation like this, when you take basically how far did I travel, in this case 6 meters, and how long did it take me, 3 seconds, what you're really doing is you're finding, this is why it's called the average velocity, because you really don't know what happened between initial and value positions. All you know is that it took you, you went 6 meters and it took you 3 seconds to do it. There's a couple of ways to go between initial, there's actually infinity ways to go between initial and final. Let's say this was initial and this was final, the paper, right? So I could start off and do it in, what did I say? It was 3 seconds. Okay. So I could say 1, 2, 3. In other words, very constant walking, very nice, gingerly, everything's constant between initial and final, right? Like that. That's one way I could do it. Or I could start really, really fast and then slow down and still make it in 3 seconds. So let me do that again, really, really fast, and then slow down and make it in 3 seconds. Between the total endpoints, I could still make it in 3 seconds. But I can also do it in many, many other ways. I could go really, really slow and then speed up at the end. As long as I make it between these two endpoints in 3 seconds, then I'm going to get the same calculation for the average velocity, because it's only looking at how far I went and how fast the entire process was. It has no information about what happened here. Did I chase my dog for a while and run, and then slow down because I'm tired? Or did I go, really, really slow and then decide to speed up at the end? Or what? It doesn't take any of that into account. That's why it's called the average velocity. It's looking at the endpoints and the time, and it gives you an average value. I might be speeding up some, I might be slowing down some, but the average velocity is the average of what I'm doing over the whole interval, all right? Later on, many lessons from now, we're going to talk about the instantaneous velocity. When we look at motion, when we're speeding up and slowing down along the interval, and we're going to figure out how that affects things. And it makes it more complicated, as you might guess. But that's kind of getting a little ahead of ourselves. I just wanted to point out to you that that's why it's called average, because you're only looking at the endpoints and the time elapsed. You have no idea what's happening in the middle. There's many ways I can get from A to B, speeding up, slowing down along the way. So average velocity is what we learn now. Instantaneous, what am I doing right now? What am I doing right now is what happens later on in the class. So for now, make sure you understand these topics. Follow me on to the next lesson. We're going to dive, roll up our sleeves, and get busy with vectors, because all velocities are vectors, all displacements are vectors, all forces are vectors, vectors everywhere. So we're going to roll up our sleeves and learn a lot about vectors, and then we'll come back to motion and keep studying that in physics. Learn anything at mathandscience.com.